In this video, I'll go over how I solve the charge of different peptides at different pHs. Now, the first thing we have to realize when we're looking at the charge is that every peptide begins with an NH3 plus and a COO minus. Now, this plus and minus is only for pH 7, but the majority of the time we're going to be talking about amino acids at pH 7 because that's roughly the pH inside of a cell. Alright, so pH 7 is the easiest pH to determine the charge of a peptide because we learn the charges of the peptides at pH 7. So when they're written out on the slides or wherever you're going to see them, they're usually written at 7. Not always, but usually. So all we need to do here is count the charges. So the N-terminus is positive 1. That's why I have a plus here. T, uncharged, 0. E, negative 1, so negative here. A, 0. M, 0. C-terminus, COO minus, minus 1. So at a pH 7, when I add up the charges, I have a plus 1, minus 1, minus 1. Overall, the charge of this peptide at 7 is minus 1. Now it becomes trickier when we go at pHs that are different than 7, but I have a little technique that I use to determine this. So the first thing you need to do is determine which amino acids have a pKa. So the N-terminus has a pKa, and we're going to say that's always 9. T does not have a pKa, so for all intents and purposes, we're going to ignore it. It does not matter. The charge of T will never change because T does not have a side chain pKa. So I can ignore it in all calculations. E has a side chain pKa of 4.3. A and M both don't have pKa, side chain pKa, so I can ignore that. The C-terminus has a pKa of 2. Alright, so once I figure out which groups, which amino acids have pKa's, I make a little table where I have my 3 residues or 3 functional groups that have pKa's. Then I list in order from large to small the pKa, pH 7, and whatever pH we're going to. So if we look at NH3 as a pK of 9, so that's above pH of 7 and then a pH of 1. So what I always do is I start from pH of 7 because that's kind of like our home base. We should always know what the charge of our functional groups or amino acids are at pH 7 because that's how we learn them. So I have pH 7 here and I'm going down to a pH of 1. Notice when I went from 7 to 1, I did not go in between my pKa. My pKa is not between 7 and 1. Since my pK is not between 7 and 1, the charge of NH3 does not change, so it remains a positive 1. Now for glutamic acid, when I write them in order, I see 7, pKa, and 1. So between 7 and 1, the pKa is in the middle. So when you are going below the pKa from 7 like this, you become neutral. You gain a proton. Another way I remember that is that low pHs mean there's a lot of protons in solution. So here I'm picking up a proton if my pH is below the pKa. But notice I can only do that if going from 7 to 1 I went below the pKa. NH3 I could not do that. Even though pH 1 is below the pK of 9, we already started below the pK of 9 when we're at our neutral pH of 7. Therefore, we've already picked up the 1 hydrogen that we can pick up. But here for E, at 7, we are not below the pKa, so we have not picked up a hydrogen. But when we go to a pH of 1, now we are below the pKa, we get to add a hydrogen, so we become neutral. Same thing for COO minus. 7 to 1, I start at 7, go below 2, so this should say pH, not pKa, go to 1, and again I gain a proton, so I become neutral. So let's do the same thing for pH of 14. Again, I'm always going to start with 7, that's my home base. I'll write my pKa and my pH in order. So here, NH3, we start at 7, and we go above the pKa to get the 14. So if I go above the pKa, I lose a hydrogen. So NH3 plus lost a hydrogen. Hydrogens are +1 charge, so I become neutral. Here for E, my pKa is not between 7 and 14, so nothing changes. I already started above the pKa when I was a pH of 7, so I already lost my hydrogen, and I'm not going to lose another hydrogen by going up to 14, so I stay at -1. COO minus, the same idea. 7 is already above the pKa of 2, so going to a 14, I don't pass the pKa. I've already lost my hydrogen at 7. I'm not going to lose another hydrogen, so I stay at -1, so my overall charge is -2. And so that's how you can solve the charge of any peptide I give you at those pHs. Something to keep in mind, for any amino acids, you're either going to lose 1 or gain 2 hydrogens. You're never going to be in a situation where you're going to go to a -2 or a +2. So just keep that in mind when you're working on these. And if it's still confusing or you still have other questions about this, please do let me know and I can help you out with that. Otherwise, I will see you in the next video.